It's not easy being in the field of data and AI. It's changing pretty fast, faster than I think a lot of people in IT even realize. And even by our standards, it's changing pretty quick. And so it makes it really difficult to keep up. This is a common feeling and something that we all face. The reality is that nobody is really ahead in all the domains that are necessary. The challenge with AI is that you need a background in data science, machine learning, computer and software engineering, as well as experience in very certain business domains. And it's tricky to have two of those, let alone all three of them, which is why there's very much a perceived barrier to entry with AI and ML. We all are getting ready for this new world, and it's both exciting and scary at the same time. And I really feel like we need to take a different approach as to how we're learning and how we're approaching AI and ML specifically. And everyone's in this race to cross the finish line. My name is Andre. Welcome to a nation of builders, and let's talk today about learning in the era of AI and evolving tech. I actually think, ironically, it's really important to slow down when the whole world is speeding up. It's very critical to focus on the foundations of what it is that we're doing. Demis Hassabis, who is the CEO of Google DeepMind, developed some groundbreaking AI technology in the first computer that was able to beat a human being at the game called Go. The challenge that we're facing specifically around generative AI right now is the fact that, we are getting very distracted by it. There is very much this new car effect where we're in the honeymoon phase of AI. And it's really important to recognize that and to understand that if we're solely focused on generative AI as it is right now, we're almost ignoring everything else outside of that realm. And that's really important. So we don't want to necessarily get distracted by Gen AI. Like, we definitely want to leverage it for sure, but we don't want to get so distracted by it that it actually stalls progress in other areas of data science and machine learning. Learning AI itself is particularly difficult just because there is such a heavy basis in backgrounds, not only in computer engineering and software engineering, but in maths as well. Now you don't have to only be an expert in one domain, but in several. And the reality is none of us are really good at excelling and becoming experts in several domains. As humans, we tend to get really good in one particular domain. There are very few people that can really be true experts in several domains, specifically the ones that are centered and focused around AI. That's where a team dynamic and knowledge sharing becomes super important. Factor in the domain knowledge that's necessary, and it further adds a degree of complexity. I'm not professing to be an expert in any of the domains, be it data science, computer engineering, machine learning. When I had this mental shift and this change to how I approach learning, I found that it really accelerated my progress in that specific domain. And it's really interesting because it's always changing and evolving. Taking a slightly different approach to it has really made a big difference in my ability not only to acquire new information but retain it, and then further to that, also be able to infer from that previous knowledge. What I'm not okay with is being too scared to try. Getting over the hump of being comfortable with failure is very much reality. And I've been doing this for a while now, and whether or not it's with you creating YouTube videos or data science and machine learning, or even my music, for a long time, I was very scared to even just try to put out something that, maybe was less than perfect. I mean, clearly I'm not a great cinematographer yet, but I mean, maybe one day I could be. That'd be pretty cool. Or same thing for a musician. And that's all right. So what matters is the fact that, we're trying and we're learning and we're adapting from it. That level of adaptation is referred to in the data science world as a Bayesian approach. So what you're doing is you're taking your learnings from a past experience and you're applying it to novel scenarios. And it doesn't matter whether the outcome is positive or negative. The fact is we're taking that knowledge and we're extending from it. We're building upon it. So I'm reading a bunch of academic books right now. For example, this one right here, which I probably will put a link in the description, around learning machine learning in a very practical way. What I wasn't ready for necessarily was all the algebra and math that it covers. And so there is an added level of challenge to me to learning that. It is very much a different approach than what I'm used to, but it is also, I'm looking at it as a positive. It's giving me an opportunity to understand and learn the syntax of mathematic notation. And it's very different than what I'm used to as far as algorithmic notation or programming languages, for example. But then by the same token, I have spent years researching design patterns for object oriented software development, and that's really where my bread and butter is. So, in talking with some colleagues, what I found was interesting was taking an object oriented approach to not only become a better data scientist, but also to apply that to my learning model. So, what am I getting at here? What is a learning model? What is a mental framework? Mental frameworks are essentially a step by step set of instructions that we use internally to say, like, okay, hey, this is my task, this is my goal, this is my outcome, this is where I'm at, and this is how I get there. We may not know it, we may not classify it, but we all use mental frameworks to do that. As far as learning models are concerned, that is very personal. It is very independent. And no one way works for everybody or may even work for anyone other than me. But what is important is understanding and taking my learnings and putting it all together and understanding how I learn best. And I've come up essentially with three key ideas. Number one, we won't retain most of the details, and that's okay. When you go through very technical documentation or very technical manuals, once you get out of the academic realm, once you get out of school, it's less important to hang on to every specific detail because we're no longer being tested or assessed on those details. How I get around that is I actually do a lot of writing. So I have books that I fill with notes to myself. And it could just be, for example, how I'm feeling about a certain topic, what my approach might be when it comes to a certain problem, or even just categorizing my thoughts as I'm going through my textbooks. And that's really important because it's not about the specific details that I'm looking for, but it's more about around the concept. So if I'm reading, for example, linear hyperplanes versus nonlinear hyperplanes to divide and separate data, what I took from that was the value of normalizing data and understanding how to interpret and understand that with certain visualizations. Now, the actual mechanics of doing that, I've got a textbook that I can go back to in the future. So as I'm building projects, I can now take that and apply that knowledge. So not remembering all the details is okay. What I am remembering, however, is the fact that that is a thing. So now I know, and it is in my general consciousness, but there are certain key factors that I'm looking for when I'm analyzing my data. And it's really important. And this concept can extend and apply to pretty much anything. If you're learning how, for example, to build a shelf, I mean, there is documentation online. There are plenty of books on carpentry, for example, understanding what types of wood glues there are. Now, you may not remember the exact wood glue or the type of nails or the type of tools or materials you need, but you understand that it is something that you need to think about. And that's where the core of learning comes from. And that's why I talk about foundational learning. The foundations are very important because now it allows us to have a starting point, a springboard, somewhere to work off, somewhere to start our research. Which brings me to my second point. Knowing where to find information is historically one of the most difficult things to do. I found that before there was code space, before there was Stack Overflow, in my particular line of work, it was very difficult. We had to rely on textbooks, we had to rely on colleagues and peers and academics helping us out. As general availability of information, so like YouTube, Skillshare, Coursera, became available, it became even easier. And once again, now we're seeing that with generative AI like ChatGPT, Perplexity, AI support platforms that are essentially just going out and coalescing mass amounts of data and distilling it down to what it is that we need and providing it to us in a very certain context. And that's very important. So knowing where to find information, be it like a carbon resource or an online resource or another colleague or something along those lines, is very important. And honestly, like you can get by and do quite well for yourself just by understanding and knowing what to look for and where to look for it. The third thing to remember is that when we're reading a book or we're talking to an individual or reading something online, it is a very limited, and even listening to me, it is a very limited perspective. So we're, even if we're reading something that somebody or a group of people have read, there is a very specific tonality to it, there is a very specific discourse to it, and there is a very specific intent. And that intent and your intent around the research may not 100% overlap. So it's important to remember that. And that's why doing your due diligence when you're doing your research and learning is very important. Generative AI itself is doing a really good job at condensing that and framing it within a certain context that's relevant to the question. That's part of prompt engineering. However, we need to always be conscientious and remember that under the hood, what's powering that is the tonality and the intentions and the agenda of other authors that have fed the model that source data. So, not everything has to be a 100% fresh idea. My approach to using generative AI is to use it to help me springboard ideas and then work from there. But one thing that I do pride myself in is having very good research skills. Being able to coalesce all that information and put it together in my own narrative is something I'm very proud about doing. And it's definitely a skill I would recommend for most people looking to get a job or to really advance themselves in a post-gen AI society. Suffice to say, everyone has a different approach to learning. And for me, building projects is very much a personal way of applying what I've learned and really fostering those neural connections that I'm making. Being able to apply the foundations and being able to understand how they all fit and piece together is tenet to what I'm doing, both professionally and recreationally. The same approach that I take to my job in learning AI and ML and data science is very much the same approach that I took when I was learning software engineering and data engineering, systems architecture, and more recently, even music, playing guitar, composing music as a producer. We also have to ask ourselves why. I read a book by Simon Sinek called Start With Why. Phenomenal book. And it's really made me think about why it is that I'm doing anything really that it is I'm doing. So whether it's at work or on my personal projects, why is it that I'm doing what I'm doing? Why am I learning how to film and edit myself? Why am I learning to create phenomenal presentations? It's not because I'm looking for clicks or views or to build a massive social following. It is extending more to my creative side. But I also have a very technical side where I am very much interested in concepts like true big data, hyper parallelization, when it comes to processing extremely large volumes of data. That is very fascinating to me. The give back is that because I'm really focused on this why around what it is, my general interest around it, my clients and my customers and my colleagues can now reap the benefit from that. So that's where I'm meeting success. And it's not that my passion is necessarily success at work or on my personal projects. It's about something else. And any success that I see from that is entirely and completely peripheral. Which brings me back to really my first point, which comes back to the whole idea of slowing down. So the reason I can start working on projects and actually use those as springboards for new projects is because even to this day, I still focus on the core fundamentals. I've been writing software for almost 20 years now, but I still go back and practice my design patterns. I still go back and practice what I preach around object-oriented principles. So encapsulation, polymorphism, inheritance, understanding the relationships between objects and entities and code, and then taking that and applying it to what I'm doing in the data science and machine learning world to build generative AI is really what distinguishes myself, right? So I'm taking something that I know I'm very good at and have a solid foundation in, which is software engineering, and apply them to the new concepts that I'm learning in machine learning, data science, and artificial intelligence. As builders and lifelong learners, it's not just what we say what matters, it's what we actually do with that. So I'm trying, I'm putting myself out there. I'm building content, I'm building music, and I'm even working on my own projects. Every voyage that we go on is deeply personal. Even if we're going on it together, we all have our reasons for putting foot on that ship and for embarking on that journey, whether or not it's alone or with colleagues whether it's academic or recreational or creative. It doesn't really matter. As a builder, I am a lifelong learner. And it's really important to understand that it's okay to be wrong. It's okay to suck when you first start out. It's okay to suck when you've been doing it for a while. The point is we're all taking from these experiences and we're all learning. And that's why I really want to start this channel as well, because a builder is someone who takes a foundation or takes a baseline and builds upon that. It doesn't have to go all the way to the sky. It just has to go marginally or incrementally up. And to me, like, that's really important, whether or not it's in my own ventures or in a professional one. Um, to me, that's really what matters. That is my why. My why is for personal growth. My why is for mutual growth. My goal and my why is to move this world ahead just a sliver of an ounce if I can, just to move it. To move the world, you just need a big enough stick. And if we're all putting together that stick, we can move the world together. Had you asked me a year ago what I would be doing, I would have said I was in software engineering full stop. I never would have told you that data science and machine learning were of interest to me. And at first it was scary. And once I got over that hump, I started seeing little joys. I started seeing little pleasures in it. And I started growing that side of me and building those foundations and making those connections into something new that I never realized I would have liked otherwise. On paper, there's nothing about data science I should enjoy. However, I do. I love the math behind it. I love the exploratory aspect of it. I love the scientific nature of running experiments and evaluating yourself on it. I love the empiricism of it. And then putting that all together to build the next generation of artificial intelligence is something that's super cool to me. And it's something I'm very passionate about. And to give back, I'm talking to my community. I've got an event tomorrow, for example, that's local to where I live. Where we're just going to be talking and nerding out about artificial intelligence and answering community questions. It gives me a chance to help spread and share the love and the passion that I have for generative AI, machine learning, and data science with others in very down to earth and practical terms. Science has always been a core of my foundation. So being able to have empirical evidence, build a hypothesis which I can challenge and test is really core of who I am. Although it's something I never could have foreseen, getting into the world as an engineer and as an architect is something I knew I kind of always wanted, never really knew how to do it, but I gotta say, I'm immensely proud of. So thanks for listening to me today, and be sure to like and subscribe this video. I'm going to have more content like this probably in the future. I think most of what I'm going to be focusing on is commentary around my projects. Drop a comment down below on what your approaches are to learning, especially when it comes to complex topics. And yeah, we'll see you in the next video.